So we're here today with Keegan. Keegan's the product manager for the intrusion detection motion detector series.
Correct.
All the detector sensors. Yep. So there's a lot that goes into this little gadget. There's there's a bunch of different choices to it, how they work, which better for which application. But one thing's for sure, I think most people take for granted that you put this thing on the wall, put some wires up to it, and there's an expectation that it's going to work.
Absolutely.
I find that understanding how this stuff works a little bit better helps me be able to, correctly locate the motion detector, minimize my false alarms and things like that. So you've got some great tools here. You got some one of a kind devices that you'll talk about here. Why don't we start talking about this and explain what goes into this little gadget?
Yeah, thanks, Steve. So we have a really cool little demonstration here that we set up. Right, it's really kind of peeling back the onion for our technology. That's the technology and engineering that's within the motion detectors. Sure. Right. So, what we set up here, Steve, is kind of a side-by-side demonstration. Right. So, our friends in video have hooked us up with the MIC Fusion to give us a thermal image. Right. And what we're showing people is this is what the detector sees out in the world. Right. So you can see my head is extremely hot. My torso's still pretty hot. As I move down in towards my legs and my feet region, we start to get colder, right? Our skin temperature is right around 90 degrees Fahrenheit, right? And when we are talking about PIR technology within our motion detectors, we're comparing the difference in temperature from the background to the target, right?
Surface temperature.
Exactly. So this is really what we're kind of trying to show here with customers. And then on the other side here, we have a one-of-one, as you said. Our engineering team in Fairport built this thing. It's been given autographs all week long. It is literally the coolest thing on the block, right? And then in this screen here, we have a detector application that has been built, right? And we've done some engineering behind the works to give us some outputs for the upper PIR, the lower PIR, microwave, and then when it goes into actual alarm, right? These are raw signals from this motion detector. We're seeing these sine waves go up and down, right?
So this is kind of a view of what the motion detector, what the device is actually seeing.
Exactly.
What goes on behind the curtain.
Yep, exactly. So when I move into the pattern, you can see negative and positive signals in the upper and lower PIRs, and when that actually hits an alarm threshold.
Smaller movements with your hand or your arm create different levels and so on. Larger movements create larger effect.
Yep, absolutely. So getting back into the technology, Steve, we have TriTech detectors, right? A lot of other manufacturers have what they call dual tech, right? PIR, passive infrared, which is the measure of temperature change.
That's this one.
Exactly. And then we have microwave, right? And the best way to explain that is kind of think of a bat, right? Sonar technology. It's not exactly like that, but it's the closest comparison.
Basically,
right?
Radio waves bouncing off of an object and returning.
Exactly. And when something walks in front of that signal changes, right? Which is allows us to see a spike in the microwave.
And again, that's why we're seeing the different levels based on what part of you is moving.
Exactly. So again, our motion detectors have TriTech. The other third technology that's built into these motion detectors is advanced signal processing, right? It's essentially intelligence logic that is built into the board, built into the programming of the motion detector, again, to disseminate, is this actually an alarm or not?
So it's basically comparing the technology information and making a decision of whether it's an actual alarm or not, meets a threshold, doesn't meet a threshold, is it a person versus another object moving through the picture, so on and so forth.
Correct. A great example of this is microwave technology, right? There is a ton of microwave going on anywhere that you place a motion detector, right? It sees through walls, so if, let's say there's a forklift, driving by on the other side of the wall, it will pick up on that microwave, right? So our detectors have the ability of seeing what is, let's say, normal in an environment, understand, hey, this is normal, and we raise that threshold, right? So we call that noise riding, right?
Sure.
So that is now our threshold, and anything that goes above and beyond that, we know that it's an actually alarm.
And you gave the example of something on the other side of a wall. Maybe that other side of the wall is not in the needed area of detection. So because that technology is almost actually too good, we want to only worry about what's on this side of the wall or in this room. We need that other technology, and then that's smart to basically say, hey, ignore that. It's not creating an event for the other technology in the space that we're in, so just ignore that on the other side of the wall.
Yep, exactly. So why are we doing this, right? Everybody knows about our Bosch motion detectors, right? They're the best in the world, they're the best in the business, they do a really, really good job. Again, we're peeling back the onion to tell the story behind the engineering that goes through all of these things, right? And what does that do for us? It can help you with installation, right? It can help you understand, where should I put these motion detectors? Which one should I actually be using, right? Should I be using a TriTech versus just a standard PIR?
Sure.
So that's really what we're trying to accomplish here.
And all that stuff is basically better performance, better results, and lower false or nuisance alarms, and which then create people getting fines, people having to go back out multiple times, rearrange where they located the unit,
Yep.
and so on and so forth. So
Exactly.
I think this is a really neat thing, because again, everybody takes this thing for granted. They basically put it on the wall, connect a couple wires to it, and then they think they're done. But
Yep.
this really kind of explains a lot about what goes on, what this thing actually sees through its eyes almost, which is really cool. And the engineering guys being able to make that one-off detector to be able to paint this information onto a screen is pretty cool.
It's unbelievable.
Thanks,
Steve.
time.
Appreciate it.